A very warm greetings to all of you, respected chief guest and keynote speaker of the day, Dr. D.K. Aswal, Director, Health Safety and Environmental Group, Bhava Atomic Research Center, BARC, Mumbai. Our invited guest and the industry partner, Dr. Tarun Sharda, Managing Director and CEO of MS Techno Instruments, Jaipur. This is a coincidence, ladies and gentlemen. We have Mrs. Aswal also with us in this occasion. We welcome you, madam. Director CSIR-AMPRI Bhopal, Professor Dr. Avnish Kumar Srivastava, respected dignitaries, scientists, researchers, students, colleagues, ladies and gentlemen, I, Dr. Sarika Verma, Principal Scientist, extend a very warm welcome to all of you on this very special occasion on the visit of eminent personality in our institute, Dr. D.K. Aswal, at CSIR-AMPRI Bhopal. We are really thankful to you, sir, for accepting our invitation and sparing your valuable time with us at AMPRI Bhopal. In the morning session, I would like to share with you, he had a visit to all the products, all the laboratories, instrument, and the facilities that we have in our laboratory at CSIR-AMPRI Bhopal. Once again, we thank you so much, sir. Now, to start the program with, I'd like to invite Director CSIR-AMPRI Bhopal for his welcome address and opening remark. But before that, I like to share his list of achievement. Although the list of achievement is very long and it is difficult to put them into the words, but I like to share with you. Professor Avnish Kumar Srivastava earned his MSc Honors in Physics from IIT Roorkee and Masters in Technology in Material Sciences from IIT Kanpur. He holds PhD degree in Meteorology from IISc Bangalore. He is known for his knowledge and expertise in the field of materials, processing and characterization, semiconductor science, nanostructure materials, composites, and so on. He has more than 325 publications in high impact journal with more than 11,000 citations with his work also highlighted in Science. He is also editor of many books related to nanomaterials, semiconductors, and many other advanced materials. It's our privilege to mention that Professor Srivastava, Director CSIR-AMPRI, has been recently identified by Stanford University among top 2% most cited scientists all across the world. Along with the deep knowledge on the fundamental science, he has also a command on the technology development and has more than 25 patents and almost the same number of know-hows in his credit. He is currently serving as a chief editor for the Applied Innovative Research Journal, and he has been very instrumental in establishing various research facilities in CSIR NPL as well as in CSIR NP. Among various facilities, one of the most important facility that has been established by Director CSIR-AMPRI is the transmission electron microscopy and electron energy loss spectroscopy that are very few all across the country. He has been the fellow of number of organizations like IIM, MRSI, Minerals and Material Society USA, MSI, and so on. It's our great pleasure to mention that now Professor Srivastava is president of Electron Microscope Society of India. He has number of awards on his name. Few of them are Meteorologist of the Year Award by Ministry of Steel, MRSI Medal, INSA COSEF Fellowship, Boycott Fellowship, NRDC Societal Innovation Award, and so on. Professor Srivastava is also serving in various committees of Ministry of Science and Technology like TIFAC, DST, Standing Scientific Advisory Group by Ministry of Mines, and so on. He has also worked as National Coordinator in Bureau of Indian Standard and contributed in the field of nanotechnology. He has worldwide contribution where he is closely associated with various institutes, and some of them are Argonne and Brookhaven National Laboratories of USA, Technical University, Darmstadt, Germany, Department of Energy, Italy, and so on. Among many prominent works, the recent achievement that we want to share with you of Professor Srivastava is how the advancement and enhancement in the R&D due to the increase in the infrastructure in the form of the Radiation Shielding Center in our institute in the recent past. Along with that, the product that has been developed and that has been transferred like radiation shielding tiles from the red mud based panels, radiation shielding concrete, parali composite, bamboo composite, and so on. And these technologies, they have been transferred to different industries. And these are the recent and the prominent works wherein he has been shown the path to us, and he has reached the heights to the AMPRI. And along with that, we have a very recent, and we are happy to share. We have the instrument also, Raman, that is going to share. We have the industry partner with us. And due to this, the continuous contribution to the Atmanirbhar Bharat, Swachh Bharat, and many more that are the India's work, it has been correlated. And the list is very much and achievement of Professor Avnish Kumar Srivastava, which is filled with uncountable number of such prominent works and titles, which are really very difficult to put them into few lines. Ladies and gentlemen, now not taking much of the time, I'd like to invite our director, respected Dr. Avnish Kumar Srivastava, for his welcome address and opening remark to the August gathering. Sir, please.
Thank you, Dr. Sarika. Namaskar to all of you. Good afternoon. We are fortunate to have with us today Dr. D.K. Aswal as a chief guest and keynote speaker. Currently, Dr. Aswal ji is the director of the Health, Safety and Environment at Bhopal Atomic Research Center. He also holds the position of Director, National Radiation Emergency Response, Department of Atomic Energy, Government of India. Dr. Aswalji is former director of CSIR National Physical Laboratory, former chairman NABL, chairman BIS MTD 33 Nanotechnologies, where I have also worked, and secretary Atomic Energy Education System. He was also in the position of various directors of CSIR labs as an additional charge while serving at CSIR. He is a well-known physicist, material scientist, and an excellent scientific leader, including administration. On behalf of CSIR-AMPRI and also on my personal behalf, I welcome Dr. Aswal to AMPRI Bhopal. At CSIR-AMPRI, Advanced Materials and Process Research Institute in Bhopal, it's an engineering materials institute under the umbrella of CSIR, and we are working on lightweight materials, nanostructured materials, cement-free and radiation shielding materials, different kinds of composites, including bamboo-based, agro-waste, marble waste, etc., biomaterials and materials solving energy-related issues, additive manufacturing and electromagnetic forming, rural technologies, implementing rural areas, implementing our technologies, and water resource management. In addition, CSIR Jigyasa program for school children, CSIR Skill Initiative Development Program for young engineers and researchers, AICT Faculty Development Program on Artificial Intelligence pertaining to engineering materials, and ACSR for PhD degree in the area of engineering sciences, chemical sciences, and physical sciences. Some of the technologies like bamboo composite as an alternate to teak wood, radiation shielding materials and tiles, cement-free concrete materials for road construction and other purposes, and conversion of 100% parali and agro waste into useful products are the noteworthy technologies licensed, and these technologies are very useful in the future for the country in terms of the waste to wealth, in terms of employment generation, and in terms of their eco-friendly kind of atmosphere, the processing, the way we are converting it into different products. Further, it is important to highlight that most of the products based on these technologies are already licensed, and many of them are commercialized also. So it has gone from lab to land, but it's still a lot to work. And more recently at CSIR-AMPRI, the first commercial grade high-end Make in India Raman spectrometer having international standards at par with any global company, has been built under a public-private partnership under the CSIR Nimitli. Nimitli stands for New Millennium Indian Technology Initiative Program. And the product with two models, CTR 300 and CTR 150, where CTR stands for C for CSIR, T for Technos, and R for are in the market. And our industry partners, Messrs. Technos Instruments, has already received one order for the higher end CTR 300 model. The topic of today's lecture, that is radiation shielding, radiation, nuclear energy and environment, by our chief guest is very important to our work pertaining to radiation shielding materials. And I wish that after having the deliberations during the and also the discussions we had during the visit of our chief guest, we may come up to have a sort of understanding for the future to develop some of the materials for a strategic sector, in particular for Department of Atomic Energy. So with this brief note, once again, I thank and welcome our chief guest at CSIR-AMPRI. I also welcome our industry partners headed by this Messrs. Technos Instruments, headed by Dr. Tarun Charda and his team, and my own CSIR-AMPRI family for this today's lecture and the deliberations which we are going to have. And sir, we all are very eager to listen to your lecture. Thank you very much. Namaskar.
Thank you so much, sir. Thank you for your kind words. To move ahead, ladies and gentlemen, I'd like to invite my colleague, Dr. N. Satish, Principal Scientist and PI of this particular Raman spectrometer that has been developed with the joint efforts of our industry partner who is already there with us. And in this actually, the spectrometer has been developed in the Nimitli program, New Millennium Indian Technology Leadership Initiative or CSIR. And regarding this, I'd like to invite Dr. N. Satish, please.
Thank you, Dr. Sarika. Respected Director Sir and respected Dr. Aswal Sir, and it is a very pleasure for us to demonstrate to you that our Make in India Raman spectrometer. So it is the first commercial grade as Director Sir has showed. So I will just give very briefly what some of the developments. Like this Raman effect was invented in 1928, and over the years, actually, with the development like in the CCDs, laser, and all other things, then slowly we started importing the Raman spectrometers in India. So, like currently, like state of art Raman spectrometers, confocal micro Raman spectrometers of research grade, almost all of them are imported in India. So like we can say that like the new development of like laser Raman spectrometers, when it is combined with the CCDs and all those things, it is like most of the Raman spectrometers are commercially not available, because commercially not, there are several developments also happened over the 100 years in lab and laboratory levels, and it was being used several publications also. But commercially availability, like when it is gone for purchases and all, it is the first commercial Raman spectrometer available in India, and which is the first order also received. And we also would like to request Dr. Aswal sir for supporting us. Also, any requirements comes from the BARC and all for this Raman spectrometers, we would like to support your support. And these are the two models which was developed. This one is CTR 150 and 300. Like 150 is for 150 centimeter spectrometer, and another is 300 spectrometer, which is having a high resolutions, highest spectral resolution possible in the given configuration, with one of the best CCD detectors, and also like like the state of art softwares are developed, and processing, post-processing of softwares are developed. And one more addition was that all these spectrometers were able to measure also photoluminescence as well as the optical emission spectroscopy. So this was developed as a Atmanirbhar Bharat, where we are trying to contribute it like in economy, like we will be able to save some foreign exchange considering an import. There are about 15 to 20 Raman spectrometers are imported every year. It's like commercially available. And with the good infrastructure development, we will be able to develop a good materials this thing with as the infrastructure. Then also like Raman spectrometer will also help in industrial applications, various industries like pharma, gem, food, security, and several industrial applications also being emphasized on that. Then on demography level, like it is developed in India and pan-India presence of CSIR and technos is there to be useful to reduce the under the demography will be able to reduce the downtime and other aspects in the having the so Raman spectrometer market is somewhere close to 20 to 30 crores per year market with the estimated growth rate of 5 to 7%. On other hand, actually, when we develop it at international standards, as our Prime Minister says, then the global market is much, much larger. It is almost 4,500 crore market with the estimated growth rate about 7%. So where we will be able to make a larger impact by preparing and going on international scales. So these are like some of the stability analysis we have like spectrometer calibration characterizations are done. So then with that angle, the project was initiated in 2021 April, and with the record time we have completed the project within a year and January 2022. The CSIR appointed monitoring and sharing committee has approved it for the marketing, and we also it was received first Raman spectrometer orders also received, and other Raman spectrometers are in pipeline with the other organizations. The same has been also communicated to the different secretaries of Government of India to give a due consideration for the Raman spectrometer which was developed under the Nimitly for this one. With this, I will thank you. And sir, I will request your continuous support. And it was you have initiated when you were director in NPL. So this we would like to thank you. Sir. Thank you.
So before going further, it's an interruption. As Satish said, I still remember I was scientist at NPL, and it was 5th December 2016 afternoon when we got it forwarded first concept note of this Raman spectrometer to be submitted to CSIR Nimitli program, because 6th December was the last date. So Dr. Tarun Sharda is here. Probably he may remember that I took him directly to director office. Normally that is not the protocol, but since the last date was there, and I was confident that after 6 years, maybe again we will sit and then we will remember and enjoy the success of this program. So we were, although it was, slow, but probably we were sure that time itself that we will get this success. Thank you very much. And thanks to Dr. Aswal that since beginning, it's basically your baby, which you have seen today. And you have seen, both the partners are Avnish and Tarun are existing on the board. Thank you very much.
Thank you, sir. Thank you, Dr. Satish, as well. Now to move ahead, ladies and gentlemen, we would like to listen from our industry partner, Dr. Tarun Sharda, Messrs Techno Instruments, Jaipur, where he is a managing director and CEO of the industry, wherein we have jointly designed, developed, manufactured, marketed, and many more things are to be there to in the near future. And we like to listen from him. Dr. Sharda, please.
Good afternoon, everyone. Thank you for inviting us here to speak about the Raman, although Director Sir has already given a nice introduction of how rather it is started with the blessings of Professor Aswal and back in 2016. And as he said, though it took some time to get the project, but at the end, as shown by Dr. Satish, the two equipments were delivered, and they both are there right now in the CSIR-AMPRI site. Some pretty good results have been obtained, which demonstrated that those are on par or better than any international standard, like what Dr. Satish was showing in his slides. The kind of repeatability, reproducibility, the highest possible resolution at the moment with the existing focal length and the kind of detectors that we have got. So all this, yes, again, to say thanks very much to Professor Oswal for signing it off, and to Avnish sir to take it forward in a very constructive, aggressive manner to bring it to us to do the rest of the job of development and bringing them up with these kind of standards in less than a given time. There are to show that, not talking technically because Dr. Satish has already taken care of it. So how that RDP, research, development and production, now we are moving from development to the production side. So about the technos, we are concentrating for technology solutions. Raman is a major one for us, but it's a new project for us, and we have successfully come up with that. Although it is on the verge of getting into mass production, because we are developing lots of applications also. So as per the demand, we are going for the mass scale of it. Before that, we had already in Technos and related sister concerns. We have that is like man-made diamond or CVD diamond, and we take pride to say that the indigenous development of our technology has taken now India into the leading position in the world market in man-made diamond. So that is of course one gem man-made diamond, and we are also digging deep into the industrial application of So we from research development to the commercial levels, which can run 24/7, 365 days. Okay, having said that, these are the two systems already. I mean, we will be privileged to have Professor Oswald to have a look at them and get some live demonstration. I hope Dr. Satish will get whatever we need. If there is anything that we need to improve further, or where we are because of his experience, we should get those feedbacks from him. Already Dr. Satish has shown this. So these are we are now into the sales and marketing of the same equipment, beside doing a multiple parallel thing, such as developing many other applications. We are getting into now the life science, pharmaceutical. We are doing the post-processing now, where we are now doing the multivariate analysis to find out the quantification using Raman of any pharmaceutical material, APIs, and in the life science, we are of the firm believer, like the what pandemic we just went through. We were the firm believer that given an opportunity, Raman would have equipment less than a minute or so. So we are into those direction of using Raman into the life science. We are able to detect cancerous cells. We are able to detect them. We have successfully detected them. So we are into working now in collaboration with various hospitals, laboratories, in developing many laser systems, which we shall be installing at ISCB Kolkata in the coming 4 months of time, which will be one of the highest standard Raman in the world with multiple laser systems. So we are already working into it, and we are also developing the Raman is essentially a very weak scattering, so very difficult to obtain the Raman signals. So we are working parallel in developing another technology. Part of it came from the same our collaborator CSIR-AMPRI of SPR substrate developments, which is also almost on the verge of commercial launching, where we have obtained nano to femtomolar concentration of detection by the Raman, which should resolve one of the very big problems of Raman. And that will again find application in food, pesticides, quality control, narcotics, explosive, many other industry. So these are the parallel activities beside the marketing and sales through the web brochure conferences going on. So we are also developing a parallel application, especially that beside R&D equipment, we should be able to bring the Raman into the industrial organizations. We make every Raman customized, and that's the advantage we bring to our users. And all these customization is basically to deliver high quality with cost efficiency, where we use 4 parameters essentially. We try to figure it out based on the application of the user, whether it'll be used for research, development, quality analysis, or quality control. So these 4 parameters make us configure the Raman to most optimized as per the budget with the highest quality. So based on that, it could be highest end Raman and going down to based on the application. So with this, I would like to take up any questions if I can answer. So this was a very brief presentation. Beside that, as Dr. Satish said, we have already received 1 order after having successfully approved it by the committee. And we have participated in 4 tenders so far, including 1 tender which is ongoing at Bhopal Atomic Research Center for quite some time now. And so I think 4 tenders we have participated. We have given demonstration on the leads to some 4 universities, including ISC Bangalore. And we have received the inquiries from some 6 to 8 institutes, including DRDO labs and all, to give the demonstration, and they are quite interested in forming the specification based on the things going for the tender, So there's a lot of activities which have started, and thanks to our team at CSIR-AMPRI, our partner at CSIR-AMPRI, with the support and many support in various areas, we are able to reach to the stage where we are receiving leads almost every day for a high-end Raman. Thank you so much, sir. And if there is any question, I'll be very happy to answer.
Thank you. Thank you so much, Dr. Sharda, for sharing your experiences as well as your future plan and the strategies wherein together jointly with CSIR-AMPRI Bhopal, I'm very sure that soon this Raman spectrometer will be there in every part of nation as well as internationally it will be there. So thank you so much once again. Ladies and gentlemen, it's our proud privilege that we have with us a very renowned, experienced and prominent personality, Dr. D.K. Aswal, Director, Health, Safety and Environmental Group, BARC, for today's program. His talk, he has chosen a talk in a way for a very unique and a special title, that is a radiation, nuclear energy and environment. Before I'll call him for his lecture, I like to share the list of achievements with you. Although the list consists of uncountable number of achievements for the well-known works and the title that Dr. D.K. Aswal has done, and it is actually difficult to put them into words. While I was going through the work or the CV of the sir, it gave me the immense pleasure that he has a wide variety of experiences in all the areas, and I'm very sure that after listening his CV, you will definitely feel the same. Dr. D.K. Aswal, Director, Health, Safety and Environmental Group of Bhava Atomic Research Center, Mumbai. He also holds the position of National Radiation Emergency Response Director, Department of Atomic Energy and Government of India. Earlier, Dr. Aswal has held several key national positions, including Director, CSIR NPL New Delhi, Director, Siri Pilani, Director, CSIR NISTED New Delhi, Chairman, National Accreditation Board of Testing and Calibration Laboratories, NABL, Secretary, Atomic Energy Education Society, Mumbai, etc. Dr. Aswal was born on June 30, 1965 in a remote village of Uttarakhand state. After completion of MSc in physics, he was a gold medalist from Ghadwal University. He joined Bhava Atomic Research Center as a scientist in 1986, where he rose to a position of outstanding scientist and was deputed as a director NPL for the period from 2015 to 2021. His visionary scientific leadership has put India several foot forward in realizing the measurement capabilities at par with the developed nation. Among various works, some of the prominent works that we want to share with you is he implemented redefined international system of units, the SI, based on the fundamental and atomic constant in the country on May 2019. He architected the National Atomic Clock Ensemble to generate Indian Standard Time IST that registered an accuracy of 2.8 nanoseconds, one of the best in the world, which was dedicated to the nation by the Honorable Prime Minister on January 4th, 2021. To ensure a safe digital India through accurate and reliable timestamps, he launched One Nation, One Time mission in which all devices clock in the country need to be synchronized with IST. He also introduced an ambitious national program on indigenous production of certified reference material under the trademark of Bharatiya Nirdeshak Dravya BND and produced them for cement, petroleum, high purity gold, water, food, pesticides, gases, etc. It's proud to share that these BNDs were also dedicated to the nation by Honorable Prime Minister on January 4, 2021. He is the brainchild of India's first certification system for the ambient air and industrial emission monitoring equipment, which is gazetted notified by the government and which was also dedicated to the nations by Honorable Prime Minister on January 4, 2021. Other national meteorological programs originated by him includes light efficiency measurements, efficiency of solar cells and modules, strategic materials, etc., which are reaping huge benefits to the country through quality controlling indigenous products. His Aswal model for inclusive growth, the national meteorological infrastructure of international equivalence, is indispensable for establishing synergy among government, academia, industries, and civil society, is a key enabler for realizing Atmanirbhar Bharat. A convincing representative of India, he has also advocated for India's interest in meeting of International Bureau of Weighing and Measures and Asia Pacific Meteorological Program. He has indigenous developed several key technologies for India's nuclear program, including single crystal for radiation detectors, hydrogen sulfides, and ammonia gas sensors for heavy water plants, catalyst bearing carts for mitigation of hydrogen in nuclear reactor, and thermoelectric power generators for the conversion of waste heat into the electricity. He has also developed numerous technologies for societal needs For example, recycling of plastic waste into the tiles, PM 2.5 and PM 10 measuring devices, new security ink for the Indian currency notes, magnetrons, and many more things. He made enormous contribution in science, education, and dissemination. In fighting humongous situation arose due to COVID-19, he steered accreditation of more than 500 RT-PCR testing lab across the country, around 26 states, with a testing capacity of more than 2 lakh samples per day. In 2016, he organized a mega science festival for the masses at NPL, which has more than 3 lakh visitors, including nearly 3,000 students from 28 states who were nominated by honorable members of parliament from their adopted village. His efforts in providing meteorological traceability to 4 lakh testing and calibration laboratories for their accurate and reliable results are benefiting small and medium industries in the quality control. His fundamental scientific contribution in many fields has led him to invite to many institutes like Japan, France, Germany, etc. for the collaborative work. He has edited 6 books, written more than 30 book chapters. He has around 9 patents in his credit and published over 500 journal or the conferences papers with current H index of 46 and citations over 8,500. Dr. Aswal had been a visiting professor or the scientist at several international institutes in France, Japan, USA, and he is a recipient of several national and international recognition, including Fellow of International Association, Sweden, Fellow of National Academy of India, and many more things. Dr. Aswal is chairman and member of several national committees of Government of India. Dr. Aswal has distinguished himself as an academic, research and development scientist, a science administrator, and a meteorological diplomat. His scientific philosophy and extraordinary contribution are decisive for India's journey towards a self-reliant nation. The list is very long, ladies and gentlemen, of Dr. Aswal, to put it into the words that I already shared it with you. Now I'd like to invite our chief guest of the program, Dr. D.K. Aswal, to deliver a lecture on a very special and the unique title, that is a radiation, nuclear energy and the environment. Sir, please. Thank you, sir.
Yeah, namaskar and a very good afternoon to all of you. As has been mentioned that I am here since morning. I saw various activities of AMPRI Bhopal and I'm really impressed. Impressed the way things have been put up, the way the scientists are motivated. And as Dr. Avnish already mentioned, that it was my dream that we should develop our own indigenous scientific instruments. I remember that apart from Raman spectrometer, he was given a responsibility of scanning electron microscope as well, and for which he really worked very, very hard. He discussed with almost all leading manufacturers of the scanning electron microscopes. He could gather in a reliable partner, but somehow we have not yet succeeded. But I'm sure that this kind of combination with Tapan Sarda coming in the picture and Raman being launched, I'm sure that we are a bit slow, but we'll succeed. Now, regarding this Raman spectrometer, I hope you might have already taken the CE certification. That is for the safety one. If not taken, please take it up, CE certification, and register it at GEM portal. And also make a very wonderful and fascinating brochure of this, which will be circulated across the country in the leading institutions. And I'm sure that it will pick it up. Now, I will talk about the presentation, which is a little different and more close to that what I'm supposed to do for the country. And the topic is radiation, nuclear energy, and environment. So let me admit that in this slide, none of the data is original. All are taken from the open literature internet. And this presentation is only for a education purpose. And the whole idea is to convince about the nuclear energy, and the so-called fear about radiation should not be there, and how this nuclear energy will change our environment. So as you know that only few days ago we celebrated our World Environment Day, and that the theme of this was only one Earth. And in the bottom, that was my New Year greeting card, which I sent to many of my friends and colleagues across the globe, which says that DAE gainfully utilizes radiation for mankind. And I'm going to elaborate a bit of that. And when we discuss about this World Environment Day, we should always read the hard effort done by the IPCC, that is the Intergovernmental Panel on Climate Change of the United Nations. So sometime we as a human being, we become very arrogant. We say that, I am the ultimate in this world. So let me take you to this Earth. And as we say that in the universe are billions of galaxies, and in our galaxies are billions of Milky stars, and there is only one Earth. So if you see here, this is our Earth. And this Earth, everybody knows that it is in a solar system. And to put the location of this is marked by red arrow. So Earth in this solar system is like this. And the entire solar system is our interstellar neighborhood. And the entire solar system is something like this. And this interstellar neighborhood in the Milky Way is like this. And this Milky Galaxy in local galactic group is almost like this. And this galactic group in Virgo supercluster is almost like this. And this Virgo supercluster in local supercluster is only like this. And this is what is called the observable universe. So now you can imagine that where the Earth is. So as you know that our human body has got trillions of tissues or cells, and one of the cell is almost like Earth in the universe. So you can see the comparison, and therefore we must preserve this Earth, because the human population have no elsewhere to go other than to live in the Earth. Now when we talk about this Earth, look at the world population. In 1750 we were not even 1 crore. And look, today we are roughly 100 crore. Now today we are roughly 700 crores, and by 2050 we'll cross almost 1000 crore. That is the 10 billion. And this population growth synchronized with the industrialization. As the industrialization took place, population also increased. Now I have already shown you our Earth. We have got a limited volume. 70% that is water, sea. Only 30% is the habitant. And if you are increasing our population, it means what? We are overcrowding. We are resulting in shortage of food and water. We will not have enough health care. We will have a fewer means of education. And this also means that the natural habitat will decrease, and that will also destroy our woodland. They will destroy our rainforest, biodiversity, and area of natural beauty. All these things will be decreased. But now, as we have got, India has got 140 crore population, we have to look after their well-being. And as the world is divided into several countries, and the progress of a country depends upon the Human Development Index, that's called HDI. And HDI has got 3 components. That is health, that means life expectancy at birth, education, many years of schooling and expected years of schooling, and living standards, that is a gross national income per capita. So these index index, that is HDI, for the various countries plotted in this curve as a function of per capita primary power consumption. The growth of the HDI depends upon how much power per capita is consumed. Unfortunately, Nigeria has got the lowest. They are one of the poorest. India is not so good, only around 0.57 or so, because our per capita power consumption is low. Look the developed nation, USA, Norway, Germany. Their HDI is almost 1, and look their power per capita power consumption, it is more than 5, where we are even less than 1. We are in the fraction of less than 1. So it means what? If we want to increase the HDI of our people, we should have the power production. We should have more industry coming in the country. Now, but when we look at the power production, how do you produce the powers? So there are various sources, and worldwide, 25,000 terawatt hour electricity is produced. And most of them, it comes from coal, followed by gas, and then hydro and other things, and nuclear has got 11%. But on the other hand, in India, majority of that comes from the coal and gas. Of course, renewable energy, solar panels are increasing. Unfortunately, nuclear remains only 3%. Now, when this coal is being used, the IPCC data shows now that the earth temperature, look at the year and the change in temperature pre-industrial, that is 1850, the temperature is increasing. And as on today, it is increased almost by 1.2 to 1.3 degrees Celsius. And there is no natural drives. It is only the human effects which are coming up. Now, why does the global temperature increases? Everybody knows that. Because we have got the green gases, carbon dioxide, methane, nitrous oxide, halogen gases. And of course, there are some good gases, which are sulfur dioxide, which can reduce the temperature of the globe. And there are many methodology by which it is thought that can we use the sulfur dioxide to reduce the temperature. Now, if you see the CO2 that is being released are largely by coal, oil and gas, and you see that as the time is increasing, the consumption is increasing. Of course, the power is being increased. And the carbon dioxide that is being emitted is for coal is 820, everybody knows that. And for nuclear, it is almost negligible. And what is more worrying factor is the mortality rate, that is the death per trillion kilowatt of hours. For nuclear, it is only 90, whereas for coal, it is 1,70,000 per year, per trillion kilowatt hours. So coal not only creates the carbon dioxide, creates the one, it also creates the dust particles, it creates the carbon monoxide, it creates the health, the mining and everything is an issue. So therefore, there is a need to replace from the coal to the renewable energy or nuclear energy. And of course, the carbon dioxide is also, and the IPCC also has said that each of the country by 2050 or 2070, they have to cut down their all CO2 emissions. And also the reserves for oil and coal is limited, and some point of time they will vanish. So we have to look for the alternate methods. Now, what is also seen in the left side is that as the temperature increase, the satellite data shows that the mean sea level has increased. That is probably because of the melting of the ice glaciers. And some of the cities, those who are very close to the sea level, like Venice, they have seen very often flooding of the sea water coming up. And you can't throw this water anywhere because you are below the sea level now. Of course, because of this population, what we are seeing here is the 1,000 square kilometers of area being reduced belonging to the forest. Forming, there is a very frequent fire in the jungles. The Australian, the Uttarakhand, the America, everywhere you see, you will hear the forest getting fire. Nature has made this wonderful cycle that is called the biodiversity cycle, which reflects the number of variety of living organisms on the planet. It forms the basis for healthy functioning of ecosystem around us, which contribute to economic, social, cultural, spiritual well-being of people all around the globe. But if the temperature increases, these biodiversity may be lost, and which is not good for the planet itself. So what is that? Now, it means that on one hand, we have to increase the power so that our SDI increases, our economy increases. On the other hand, we have to worry about the biodiversity. And how do that? So, of course, coal is not a good solution. Oil is not a very good solution. We need clean energy. Clean energy in terms of the renewable energy, in terms of the nuclear energy. And we need to preserve the biodiversity. And this has worried the United Nations, and they come for the Sustainable Development Goals. And everybody knows that they have got this 17 Sustainable Development Goal, and everybody that no hunger, and you have got the climate actions coming up. So coming back to this, when we know that nuclear energy is least CO2 producing energy source, it does not kill people, then why the nuclear energy is not taking a rapid growth, neither worldwide nor in India? So this need to be understood. Now, if you look the world scenario, this is the football where the contribution of nuclear energy from each of the countries are coming up. United Nations, they produce 30.9% of nuclear energy of the entire world. France 13.3%, and if you see India is only 1.6%. Now, though they produce 30.9% of the nuclear energy, this amounts to be 50% of their total energy production. And for France, it contributes 70% of their total power production. Now, on the right hand side, what I show you, the number of existing nuclear reactors and the change since 2011 in 1 decade. Now, America has got 93 nuclear reactors, which produce 30.9% of their nuclear energy, or 50% of their nuclear energy. Unfortunately, you can see that they have lost 11 reactors because of the aging effects. And the typical age of a nuclear reactor is roughly 60 years, 50 to 60 years. It means what? They made these reactors long ago and they have utilized their life cycle. Similarly, France, 56, they have got -2 because of aging. Look, China. As on today, they have got 52, and in last 10 years, they have added 39 new nuclear reactors. Russia, 38, they have added +6. And look at India. Of course, Japan has got -13 and because of the Fukushima, but they are reviving back. So this has become a little over. India, we could add only 1 reactor. So why this is happening? You know, why the nuclear energy is not getting that much of what's so called the support from the public? And essentially it is because there is a fear about the radiation among the people. People feel that it's very scary, and they keep on telling us the story of Hiroshima and Nagasaki. It's a very dangerous this, that. And people do not understand what radiation is. And this is one of the nuclear power plant. And this is one of the photographs taken in some of the, we all time oppose. These nuclear reactors are very bad, they should not be installed. And this delays our progress for decades. And as a result, it is a loss to the country. But on the other hand, these people, those who are opposing, when they have got some problem, they will go for chest X-ray. When they have got some problem, they will go for the CT scan. And when they eat this mangoes and fruits which are irradiated with gamma rays, they will have no problem. So somehow this public fear need to be addressed. Now the fundamental question is why people are scared of the radiation. Of course, radiation cannot be seen. it cannot be smelled, it cannot be felt, it cannot be tasted. So it almost becomes like a ghost. And in my childhood, my grandmother used to say that, don't go outside in the night because there's a ghost. Because we can't do anything. So radiation almost becomes like a ghost. It is my grandmother who tells me, who trains my brain what to do. Unfortunately, that time we didn't have a meter-like instrument, GM counter, which can measure even a single photon or single ionizing radiation. So scientific community, there's a detector available with you. You can measure what kind of radiation is in and around you. Now let me go to the history of forming the Earth. We all have read that to begin with, Earth was a red hot ball and there was a lot of ionizing radiation. It went a coolant and then this, and sometime the life evolved. So universe was created around 12 to 15 billion years ago. Life on Earth began nearly 4 billion years ago. Now, when the life created, imagine we are already in the zone of natural radiation, which is too large a radiation that point of time, because there was no proper building of the atmosphere of the Earth. Now imagine if we think that radiation has got only one role to destroy things the way we perceive, life would have never evolved. So the life on this Earth evolved despite of having the radiation. It means that radiation has got a certain positive effects. And then because of the mutation, we became from the hominid to the Homo sapiens. But the real understanding of this radiation, it began only 125 years ago. So just to tell you that this is the Earth, we get radiation from the cosmos, cosmic radiation. We get the radiation from Earth. And at any point of time, on an average, we get 2.4 millisievert. Millisievert is the unit of the radiation we receive. So we get 2.4 millisievert a year while sitting at any place. In fact, in many places, we get up to 7, 10, even 100 millisievert a year. So we have got cosmic radiation, we have got extraterrestrial reactions, we have got inhalation from the air, and that is coming from your food and water. Even when you eat your banana, when you drink milk, you all get the radiation in your body. And the evolution, as the cow has gone this one, so the nature keeps on getting the new kind of flowers, new kind of these and that. That is because the radiation induced slow mutation, they create a new kind of creature and biodiversity in this Earth. But coming back to the scientific history, everybody knows that Ranjan discovered the X-rays. And how he discovered? Accidentally he discovered once he was hitting a beam of electron on a metal surface, and he has kept a fluorescent screen little far away, and he saw that the moment the beam impinges upon the target, this fluorescent screen glows. And he took no time in understanding that there is a new kind of rays which he called the X-rays. And he was bold enough, and his wife became more famous because this is her left hand for which he has taken the X-rays. And this X-ray became very popular because of the broken injury we could see inside your bones, and it was used everywhere. Of course, in France, Henry Becquerel was little upset. He said, why we need electrons to create this kind of X-rays? Can we get it from the solar light? The solar light impinges on a material and we get a radiation. So Henry Becquerel was a very much interested on the minerals, rocks, and he has got a large amount of collections. So after the Ranjan discovery, Becquerel got one mineral, and he planned to do experiment in Paris. So he was waiting for sunlight to come. Unfortunately, in winter, the Paris does not see much of the sunlight. So he got frustrated. He kept that film roll around the this mineral and locked in his drawer, which is completely dark. And a few days later, when the sun came, he opened a drawer and he saw that the film is already developed. It means what? It means the mineral itself is radiating the X-rays or some rays, and that is called a Becquerel ray. So he didn't know what is the origin of that. And then everybody knows that. He got Marie Curie to come his lab and say that what are the elements which are going to emit this kind of radiation spontaneously, which is known as radioactivity. And Madame Curie discovered two elements, polonium, that is stand from the Poland of our lovely country, and another was the radium. And they got Nobel Prize for this discovery. Now, then the science started interestingly going up. People have started looking the nature of atom. And then everybody knows that Rutherford, who not only discovered the half-life and radioactivity of radon, he also suggested the first model of atoms. And when Chadwick, who also got a Nobel Prize for discovery of neutron, then it was that neutrons and protons are in the nucleus and electrons are around. So it became clear that alpha, beta, and gamma, these are the radiation, they come from the nucleus. Electrons are outside and they give you all kind of radio, microwave, infravisible, ultraviolet rays, up to X-rays if you knock the core electrons, but gamma rays come from the one. And the radiation is one. The radiation goes from radio wave to the gamma rays. And each of them, they have got applications. Radio waves in transmission, microwave in cooking, infrared in your remotes, visual light. If there's no visual light, we can't see anything. Ultraviolet, X-rays, gamma rays. And the beauty is that this radiation can be shielded. And that's why I was very happy at AMPRI Bhopal for gamma rays because they have a large energy, they can penetrate deep, and therefore either heavy mortar are used or lead seeds are used. And they have come up with a solution which has neither lead or nor toxic. And that is based on the red clay. And if this, they have already matured this technique, and I hope after government clearances and with the public partnership, private partnership, if this comes in the market, it is going to change the future of radiation and nuclear energy and its application, which I'm going to talk in a while. It will revolutionize. So I'm very happy for AMPRI that they are working upon that. So everybody knows the half-life of the radioactivity, that when this is spontaneous fission, spontaneous emission, and the number of the time at which the amount of the radionuclide reduces half of its original value. And different materials, different radioactive nuclide has got different half-life time. For example, lithium has got only 0.8 seconds. But look at uranium-235, 703 million years. It means that ever since the Earth was built, the uranium is still there. Uranium is not going to go anywhere for so many millions of years. So the beauty of radioactivity is that it gives you the feeling of the Earth. In fact, the first human who was found on this was Lucy, and I was fortunate enough to see her skeleton, and her dating was done based on the K40 radioactivity. And as I said that it's everywhere. Your body is emitting. If you take a coffee, it is there. You eat a banana, it is there. You sit in a home anywhere in India, everywhere, you will get this one. You have got a smoke detector, it has got a radiation. You go to medical diagnostic radiation. You have a coal ash, you have a radiation. Kitchen granite, it has got a huge amount of radiation. Don't worry about that. So radiation is everywhere. Okay, you go to fertilizer, you have got the huge amount of literature. No, I always salute. She is my role model, Madame Curie. You see, those days he was using, as a chemist with wearing that white coat. I have shown that photograph, taking the radium with hands and writing on this one. This is original diary. And in this diary, and I was lucky to see this diary also. So this is made of radium. It has got a half-life of 1600 years. And she was working on radium ever since she was very young. Now only 100 years have passed since this diary was kept there. 1500 years will take only half. So the glow of this diary will go only after 3000 or maybe 4005 years later. Till that time, it will keep on glowing. So, Madam got 2 Nobel Prizes. Her 2 daughters, they got Nobel Prizes. She died at the age of 67. Of course, there was leukemia. And 67, those days was a good age. So imagine a person working with the radiation all the time could survive 60 years, 67 years, and her two daughters got also Nobel Prize. It means that radiation neither had a strong influence on her, neither on her daughters. And when this radium was discovered, there used to be a huge amount of skin cancer those days. And this radium became a quick fix treatment. Say, for example, this lady has got this big cancer. Just they put a radium on top of her, this one, and after some time, this used to vanish. So the American Medical Association that time, they allowed it, radiation therapy for the treatment of so many stomach ailments and cancer and whatnot. Not only that, the female always, they always like to be, have got a affection for the talcum powders and this one. And imagine when you put some of the radium in your cheeks and walk around and when you are glowing. So that was a fashion. And for male, always they want to become strong. And they have got this radium drink. So those days they used to drink. And it was quite fashionable. Unfortunately, this big incident happened. The wall clock business was growing. And one of them we might have seen, and we still see it at airport and other places, where the thing starts glowing in the night. And these girls, poor girls, they were using that paintbrush, dipping in the radium solution and sharpening with their mouth and putting on these numbers very cleanly. In the process, they got deposited a huge amount of radium in their jaws and inhaled. Consequently, many of them, they got this cancer. And many of them, they got the radium deposited in their bone joints and got eroded. But remember, they were doing enormously. The quantity was too large. And that created a large amount of panic in the world. And then people started saying that radiation is not good. Now, what has happened in 1942, the Enrico Fermi, you see, that's why the scientific abilities are enormous. Look, theoretically, one big atom is there, you hit with a neutron and you create a fission, and that energy needs to be converted into electricity. And demonstration of that. So that was Chicago pile was discovered. That is the world's first nuclear reactor. Imagine when this was discovered, the entire oil and coal industry, they got a cold feet. They thought that now we have got our challenger, and if this, because one fist of uranium is equivalent to 10,000 trucks of the coal. So when this is a comparison, this does not give you any negative one. Look the size, very small size. So the coal and oil company, they got scared. And that has got why the fear of radiation increased. I will come to that. Of course, the World War started. And then they were asked to make these bombs. And in fact, they have dropped also on the Hiroshima and Nagasaki. And that created more further fear of this one. Now, I don't know whether you all people are aware of this or not. Most of the so-called developed countries, those who have got a veto power today, they have tested over 2,000 nuclear tests and as large as 100 megaton. Remember, the Hiroshima and Nagasaki were only 20 kiloton. So after testing 2,000 nuclear tests on the surface, under the sea, on the ground, in the air, everywhere, and then they started saying that don't use nuclear energy and this, and because radiation will have effects. As I said, that Nagasaki and Hiroshima is the worst day in the history of civilization. Nagasaki, 40,000 people were killed roughly. Hiroshima, around 80,000 people were killed. But look, when a nuclear weapon or atom bomb blasts, most of its energy goes in terms of the blast waves. 50% of the energy goes in the blast wave. It means anything which comes here because of that vibration energy, everything is teared into apart. Then next is a thermal wave. The temperature goes billions of temperature. And look the Hiroshima below, one of the oldest figure. Everything which has come that became in the vapor. And that cloud, mushroom cloud is nothing but whatever was there on the earth, that got vaporized and it is here. So all human beings which were in and around animals, plants, they are seen here now in the form of atoms because of this temperature. Now the ionizing radiation is only 15%. And since they are ionizing radiation, there is a year it gets attenuated. In fact, the ionization cannot travel very far away because air blocks it. It is a natural shield. But most of the blame has gone to the radiation. Now, why this blame has gone to radiation? Now, there is a twist here in the story. In 1926, there was a biologist who used this fruit flies known as the Drosophila, and he bombarded them with a high dose of X-rays. And it is the cell, when you bombard the ionizing radiation, you can have this DNA broken. And when this DNA breaks, either it gets repaired or it does not get repaired. And when it does not get repaired, it can lead to the cancer. And what he proposed that as the dose increases, your cancer probability increases. It means there is no threshold. It means even a smallest photon, even smallest energy of the background radiation can create you the cancer. And this is known as linear no threshold model analytic model. So when he published his paper in Science or Nature, many people questioned. It is a almost 1 and 2 pages note. Many people asked for the raw data, and he could not provide the raw data. And there was a large amount of controversy on the Muller's Nobel Prize, Muller's data. 1945, the Hiroshima and Nagasaki takes place, and surprising in 1946, this man gets the Nobel Prize in the medicine, physiology and medicine. And that has created a problem. So in 1927, when he said that there is a linear relationship with the cancer probability with the high dose, it was at very high dose. Now he has got a colleague known as the Stern. He participated in the Manhattan Project, which I have already shown you, Chicago Pile. And he's one of the collaborators, Ernest Kasperi. He also did the same work, and he found that in the low dose range, that is nearly up to 100 millisievert, there is no mutation. And if you see, as I told you, that we have got trillions of cells, and every day in each of our body, around 1 to 10 cells, they become cancerous. But nature looks after that. And if you consider that part, that amounts to 30 millisievert per year dose, naturally without any exposing of that. So the question was that whether the Muller was aware of the Kasperi work. There is a threshold? Probably yes. And it is the strongest blame on any of the Nobel laureate. He mentioned clearly, he said there is no threshold. And even after that, he started writing that there is no threshold. And that became a problem. So disproving this LNT model became a big challenge for the world. Of course, then there are many studies which in fact shows that at a very small dose, the probability of cancer in fact decreases compared to the natural level. Only it is the higher dose which it increases. So at low doses, what happens that when the radiation falls, the biological system goes against it. It is almost like the vaccination. We have all gone through this vaccination program. Vaccination is what? It is a low dose of the coronavirus itself. Low dose of vaccination. When you do exercise, we kill so many cells. And even when you take the homeopathy we take because of this hormesis effect. And it is well said that if low-level radiation did not have any beneficial effect, it would be anomaly to science. We have all an incredible immune system. Each cell in our body suffers mutations from various attacks daily. Whatever we eat, I've already given you. Without such an immune system, we would never survive. And as I said in the beginning, the birth of life in this earth was in the presence of humanity. So the question is that, and this is a big debate, whether the low radiation is beneficial. Forget our LNT model, but still we obey the LNT model. Jam ho gaya. Just look at it. Okay, now this is the data on the atom bomb survivor. Okay. This is the data on atom bomb survivor. Now, what was seen is that those who were exposed with a very low doses, their probability of cancer has gone down. Whereas at higher dose, of course, the cancer increases. Now, in fact, when the international community were dividing that whether LNT is good or not, there were many cases. For example, there is a case of Taiwan, there is a British radiologist, Mayak, NSWS, where many people were exposed to the low level radiation doses, and it was found that their average cancer probability is lesser than the normal ones. So there were many experiences. But unfortunately, of course, we had this Chernobyl accident. The entire reactor was blasted. 134 persons were affected. 28 died soon after the accident. 106% remained alive. Out of these, 22 died within 10 years. It means the mortality rate was 1.09. But if there is no one exposed by the radiation, Russia will have the mortality of 1.38, Belarus 1.4, and Ukraine 1.65. It means what? The radiation did not harm that much. Imagine of the Union Carbide of the Bhopal, if the chemical would have exploded like this, like the Bhopal did, what would have it done? So look, the point which I'm trying to say that even the entire reactor was blasted, only 28 died. Similarly, Fukushima now. I am showing the two pictures. One is left side is the city. Entire city was blown off. More than 15,000 people died. On the right hand side, same place, but look at the construction. Nothing has happened to the nuclear construction. It remained intact. Not a single thing blew away. It means the nuclear reactor construction is so strong that it does not care about a tsunami. Unfortunately, the power supply failed because of the water going to the fuel rods. They were hot. The hydrogen production started, and hydrogen led to the blast of the reactors. Now, once the reactors were blasted, number of fatality caused by excess radiation, 0. Number of injury caused by radiation sickness, 0. Number of latent cancer expected from the cancer, 0. But look at the newspapers. So that's why sometimes I feel that newspapers do not give you the right kind of information. No, all the worldwide there was the headlines. Nobody is talking about the 15,000 people died because of tsunami. Where nobody died, reactors adds to horror, threats to the meltdown, drop Japan, all sense. So the tsunami is the issue, not radiation. Designed for huge tsunamis, the cities. Reactors are already designed for any kind of tsunamis. Of course, the power failure was there. Now that has been corrected. Now, in my opinion, to the world, this is the finest hour of the nuclear power. Despite of the entire city swiping away, nothing happens to the nuclear reactor and nobody dies because of radiation. But if you go Brazil, they take this kind of meter and there's a full of thorium, which is full of radioactivity. And they do very regularly because they feel energized. Particularly when they have got the knee pains and joint pains, they go to. In Japan, in Czech, in many places, they have got the radon therapy, where full of radioactivity. They go and they feel refreshed. And honestly speaking, in Japan, I also visited this one, and definitely you feel energized. So that low-level radiation dose, definitely, in my opinion, is good. Now, in India or in the worldwide, we use this nuclear reactions or nuclear isotopes or radioisotopes, radionuclides for diagnostics, for your analyzing your heart functions, hypothyroidisms, bone scans, lung scans, in blood, you can't do that without until unless you inject the one. And similarly, this is a Bhabatron which is made by BARC and utilized across the country and entire world. This is also used for the treatment. Now, X-ray cannot give you, which can give you by the radiographs. Similarly, the radiotherapy used for treating cancers. So everywhere you're using radiation, but at that time we are not scared of. Only when there is a nuclear reactor, we are scared of. So there is a hypothesis which was floated in our brain, and we are still working on that. If you want to go space exploration, we want to go hundreds of years, what do? We use a radioisotope as a power generator. You denture, those who have got a very beautiful denture in artificial, it is a uranium is there. When you have got a pacemaker in your heart, there is a radioisotope. This is the boon, one should realize. Now, as I said that in the earth, the cultivation area is shrinking. So we need a seed which has got a high yields, which has got disease resistance, which is adapted, which has got the better nutrition. And BRC has produced 49 varieties of seeds. Now they have gone to 55 in terms of the groundnut, cereals, and so many seeds. And most of the urad dal which you are eating now in the country, probably it is from the variety which BRC has produced. BRC has produced only 55, but to ensure the food security, the Food Organization, FAO, Food and Agriculture Organization of United Nations, and IAEA, they have generated 2,672. If you have to feed so many people, we need to have the high quality of the seeds, and that can only be achieved by the using the radiation, mutate them, and create a live one where they have got all the advantages. And in my opinion, this activity, this research should enhance in our country. Food irradiation. You see, if the fruit is not irradiated with radiation, it will spoil like anything. So all our export of mangoes and fruits or meat and shrimp, which goes to America and other things, it is mandatory by America that they should be irradiated. Otherwise, these microwaves, bacteria, parasites, they will kill these fruits and they will not able to reach there. And when you eat these fruits, of course, you'll get a food poison and we may die. So just to give a feel again, if I am sitting next to someone or sleeping next to one, I get 0.05 microsievert of dose. Now, if I am living outside a nuclear reactor, like in Tarapur, those who are staying in the campus or colonies, they get only 0.0 microsievert. It means as if we are sitting with the two people, that's all. Now, if you eat one banana, you get 0.1 microsievert because there is a huge amount of potassium. If you are living miles of the coal power plant, you get 0.3 microsievert because the fly ash has got a large amount of radioactive elements. So it is almost 1 order of higher than that. If you take an arm X-ray, you get 1 microsievert. If you use your monitors, CRT monitors, or this one, you get 1 microsievert. Now, if you take a dental X-ray, you get 5 microsievert, and all put together, this becomes like this. It is only 60 microsievert. Okay, and if you are traveling by air, say from Delhi to Bombay, you will get roughly 40 microsievert. And by natural itself, background itself, as I told you, we are got it to 2.4 millisievert. So background is 2.4 millisievert, and all these put together, they even do not contribute half of the sievert. But if you take a chest CT scan, it is equal to 7 to 10 millisievert. So we are worried about a nuclear reactor which gives only 0.09 microsievert. But when you are exposed to a 10 millisievert, you are not able. So that kind of fear is given by that LNT model, which, like a ghost of my grandmother, said that radiation is very dangerous. That's all. But when it is being, we are using it, we don't care about it. So this unnecessary fear which has been created because of LNT model. About after this Chernobyl accident, about 1 lakh European women, they choose unnecessary abortions. And there were neighboring country, they did not choose the abortions and their child had no effects. So that is the killer. As I said that nobody dies because of radiation. But since the fear of radiation was created, those who were in the ICU, the old people, they were asked to vacate the place, and 1,600 actual deaths in Japan took place in Fukushima because of the evacuation, but none from the radiation. So if that LNT model would have been not been, and if we had said that at low days it is a beneficial, things would have been a problem. Even today, food security is not achieved because we do not irradiate. And many times, most of the hospitals, in India, we have got only 200 hospitals which has got the nuclear medicines, because rest of the people, they cannot spend money on dealing with the very low level of waste. In my opinion, is not required, but as per the regulation, that is required. So in India, we have got only 200 hospitals, because we keep accounting of each and everybody who are working in the radiation in the country. So in my opinion, if that LNT model would have not been there, there would have no fear. We could have increased large number of nuclear medicine in the country, and the pain of our citizens could have been reduced. And the electricity, which has become very expensive, mining, milling, enriching, we have to put so many of safeguards, so many of restriction, the public agony, and that is creating its cost. But let me appreciate the current government. They have asked us to go ahead with the nuclear reactors and to increase the 14-fold increase in the power to reach up to the 63,000 megawatt by 2032. And this is a map, not mine. It is by some newspaper. So these are red ones are operating, orange ones are under construction, and blue ones are the proposed. Now, once we have a large amount of radiation, we are going to reduce the carbon dioxide, or we are going to have a good earth. At the same time, we can generate to large amount of radioisotopes, as I given you examples of agriculture, medicine, energy, industry, transportation, space travel, everybody where we have got the application. Public safety, arts and science, the old painting, the sculptures, they can be preserved, and environment, because it does not pollute from the carbon dioxide. So from the scientific point of view, what I was saying that above 100 millisievert is a huge dose. It has been proven that high dose will create a cancer probability. It will be dangerous to you. But at less than 100 millisievert, I am firm believer that it has got a hormesis effect. It means at low doses, it is beneficial, as nature has been giving us these low doses. And therefore, if we accept this hormesis effect, this LNT model in this zone should be demolished. But this requires more scientific investigation. How a radiation interacts with the biological cell. And what are the implications? How the cell repairs. When we get injury, it gets repaired automatically or not. Similarly, when radiation makes any damage, it will get repaired automatically. So, similarly, if you do the photosynthesis, you sow a seed, it gives a plant, and you have got a chlorophyll. And what it does, it picks up the carbon dioxide from the air, it takes that light. And those who worked in the solar cell, because these molecules are magnesium thiocyanin, when the light filters, the magnesium forms an exciton, and that exciton has to travel. So I myself worked on the solar cells and found that the efficiency of transporting this exciton is not even less than 1%. But nature does it with 100% accuracy. It produces billions of megatons of greenery without our knowledge. And that is because the quantum biology, the term which has been recently pointed out, how the nature does the efficient phenomena like photosynthesis. That is not yet understood. So humans is little very far away. So this also gives you a new area of research where radiation and biological cells that need to be understood well. So this is a point of controversy. There are various models and that need to be examined. So this is my last slide. Coming back, we are a very tiny on our universe, like a cell in our body, and we have nowhere else to go other than this earth, and we must preserve this earth. Thank you very much.
Thank you. Thank you so much, Dr. D.K. Aswal, for such an informative talk. Really, sir, your talk was very simple, easy, and understandable and full of knowledge. You have beautifully simplified the ways how the radiations are important to all of us. You started from the history to the present and the future about all the aspects. You talked about the natural disaster, floods, and fire in the forest, and wherein how and why we need the clean energy and we need to preserve the biodiversity as well, and what is the role of the nuclear energy in this that you have started with. You talked about the 17 sustainable development goals as well, a number of operational reactors in the different countries. You talked about the fundamentals of radiations, how these radiations are useful, and how the nature has beautifully utilized these radiations for the mankind. A very good example is, of course, the photosynthesis that you shared with us. And you have shown a beautiful pic of Madame Curie notebook. Really, that original book has mesmerized all of us. And you have also shared very rare and oldest pics with us, which was very nice. And you talked about different accidents and incidents which occurred, and in the Chernobyl accident, Fukushima, etc. But at the end, you have shared that the importance of the radiation is there in different sectors, in all the sectors, and which is very much important for the sustainable development. And therein, we in India is working towards this area. Thank you so much, sir, once again for such a nice presentation and correlating the radiations, its importance to the environment, to the human being, and the future. Thank you so much once again. Now, ladies and gentlemen, to move ahead, now I'd like to request our director, respected Professor A.K. Srivastava, to kindly present a souvenir of CSIR-AMPRI Bhopal work to our chief guest of today's program, Dr. D.K. Aswal ji. Sir, please, I request you to kindly present the souvenir to sir. Sir, this is a very unique souvenir, ladies and gentlemen, we will see. This is made up of the indigenous technology from the AMPRI itself. From the red mud, we have developed the radiation shielding panels, and these panels have a very unique property of X-ray radiations that has been done. And you can see that sir is opening this souvenir, and in this souvenir, what we have done basically, the red mud is an aluminum industry waste. All of us know that. Beautifully by ceramic and the chemical routing, the chemical composition and mineralogical phases of the red mud, which is naturally present, that has been converted into the upgraded form, and therein we were able to develop this souvenir, this particular technology. And this, you can see, it's there in sir's hand, and he is presenting. I would request sir to show it to our audience as well, so that we can see that how beautifully we have made this souvenir, sir. Yeah, ladies and gentlemen, you can see that our chief guest pic is there in this souvenir with the name encarved in this special type of panel that we have developed in AMPRI Bhopal using the red mud aluminum industry waste, the panel radiation shielding panel. And in this, we have made this. And this we can see. Now, I think all of us can see this. Sir is presenting to our respected chief guest. I would like to request to have a photograph, Mr. Anup, please, of this special occasion, a memorable and the unique occasion with all of us, with all the audience and AMPRI family. Ladies and gentlemen, once again, I thank you, respected chief guest of today's program, to be here with us since morning and motivating us and giving us all the ideas how to proceed further and how the technologies and the society can be benefited at the end. Thank you so much, sir. This we have another photo shoot going on in the director's office. Related to this particular gift that we have presented a unique souvenir, a unique gift from AMPRI's technology that we have developed here in our institute. Sir is liking this. Thank you so much, sir. So if you want to say something to the audience, like about this particular special type of a unique souvenir that we have presented.
Yeah.
Sir, please.
This itself is a message to everyone that what kind of radiation shield the AMPRI is making. And I'm going to keep it in my office probably and tell people whoever comes to my office. And since BRC and myself are dealing with now radiation, so it is going to be immensely useful educating the people that India has discovered a new kind of radiation shield which is free from the lead, free from the other carcinogenic materials. So thank you very much, and I'm very happy with this memento.
So, thank you very much to Dr. D.K. Aswal, whom I know, I think, from 2012 or 2013 onwards. Our first meeting happened in Kanyakumari, in some hotel where we were from NPL and BRC side for a joint project on thermoelectric materials. That time, I mean, I think at least I never thought that one day sir will come to NPL as director. And then further, I never thought a day will come when I'll be in AMPRI and sir will come here. And it's a very long journey. So it's about 10 years we have spent together knowing each other. And as in the beginning, he said that it was his brainchild after our present Prime Minister Modi ji took over, and the manufacturing of equipments in India. So in that case, this Raman spectrometer gives an example that even if we are slow, but we are sure. So that shows the success, and anything which is new with the concept wise, there are so many things which we have to take care, and whether it is technical, non-technical, official rules, protocols, and all those things. But definitely this will give like an example to others that yes, whatever we think, we can do it, and it is going to contribute to our this program mission of Atmanirbhar Bharat. And as sir said that this radiation shielding materials is really a unique program in a larger scale coming up in the AMPRI, and in the years coming together in future, it is going to benefit the country and the world. So thank you very much.
Yeah.
Namaskar.
Just so last thing which I will say, nobody knows and probably people are not aware that DAE constitute only 15% of the radiation workers. 85% of the radiation workers are in the cities, in the town, in your district, villages. Those are dealing with the radiation in the form of X-rays, nuclear medicines in the form of isotope, in industries looking for the non-destructive testing, and we keep the dossier of each of the person. And from that angle, I definitely see that the radiation is going to see much, much better important role. As I have already shown, that it has got a role in the agriculture, it has a role in the food preservation, it has got in the name the topic and you will find that. Now in the waste management, we have already put a big plant based on radiation at Surat, where the entire excreta, human excreta, can be converted into the very wonderful fertilizer. So many things are happening, and definitely low radiation is good, but high radiation is dangerous. And you can have the analogy with the fire. Imagine if there is no fire, we cannot survive. Civilization cannot happen. We need a fire to cook food, these, that, you know. But if this fire becomes uncontrolled and becomes too large, you know what will happen. So radiation is under that one. At very low controlled way, it is a very good. Uncontrolled way, very large quantity is very bad. But unfortunately, giving an example of the Union Carbide case, one chemical reactor blasted, it killed almost everyone in the city. Hiroshima and Nagasaki, two blasted, most of them died because of the heat and wave. Almost very few died of the radiation. Chernobyl and Fukushima, so many people died because of other reasons, not because of radiation. So people have to understand that. People have to adopt in our life. And anyway, we are blessed with the background radiation, and probably that keeps us alive. Thank you. So this radiation shield is going to be a game changer. This is what I'm trying to point it out. And for that, we should speed up. If we get a low cost radiation shielding, that is going to reduce the price of treatment in a big manner. So this is definitely a game changer in my opinion. Thank you.
Thank you so much, sir. I am very sure that with the proven excellent expertise of CSIR-AMPRI Bhopal and the BARC, definitely we'll have many new things in the near future, and we'll have the new things which will be definitely helpful through the society to the nation. Now to move ahead, I'd like to invite my colleague, Dr. Shabi, scientist, to deliver the vote of thanks. Dr. Shabi, please.
So thank you, madam. So good evening, ladies and gentlemen. It is a great pleasure for me to deliver a vote of thanks on behalf of CSIR-AMPRI. So it is first of all, I would like to thank Dr. D.K. Aswal for accepting our invitation and coming from all over from Mumbai, from a pleasant weather to the scorching weather at Bhopal, and giving a very wonderful lecture on radiation, nuclear energy, and environment. In particular, he has started. So what is the role of energy for the Human Development Index? And then how this nuclear energy can improve the HDA of India, and what is its role, and how this nuclear energy is more safer than compared to all the other energy sources, and how it pollutes, and what are the drawbacks of other energy sources. And he put especially all in the data wise, and also he has shown how you have to use the radiation with care, not with fear. He has shown how the radiation affected the people. Whoever has used it unknowingly in a improper manner, it caused a lot of side effects like cancers. But using the radiation with care will lead to a beneficial purpose. So he already removed, by his lecture, he has removed the fear about the radiation. Thank you for this wonderful lecture, as well as he has visited the whole lab in the morning, and he has interacted with all the scientists as well as the students, and he has also given the ideas. He has interacted, so it has really enlightened us, and it will do better research. As you mentioned, we are sure we will be coming up with low cost radiation shielding material which can be beneficial for the the public. So I thank you, sir, for coming. So then next I would like to thank Dr. Taran Sharada from Technos Instruments for making this Raman, that is CTR 300 and the CTR 150. He has explained about this, what are the merits, or how does it differ from this existing Raman, what is advantages, as well as what is additional features like photoluminescence properties and other expertise of Technos Instruments, like growing these diamonds of single crystal diamonds to polycrystalline and so on. So I also would like to request him to further come up with CSIR-AMPRI's technology to make better resolution, Raman with better resolution using SPR technology that taken from CSIR-AMPRI, and we are waiting for that. In this context, I would also like to thank Dr. Satish for giving information about how this Raman is going to improve the economy of India and how it will reduce this export, it means import of other ramen, and how it can help to grow the GDP of our country. So I will thank you for both of them, Dr. Tarun Sardar as well as this Dr. N. Satish for giving this beautiful lectures. And also I would like to thank our director for always bringing such eminent personalities to CSIR-AMPRI who are working in the relevant field, but with the aim to make new collaborations and bring new projects and new technologies. So it says already enlightened with many such visits, has already made a lot of joint projects and MOUs and joint publications, joint patents, and so on. So I'm sure that this visit of Dr. D.K. Aswal will also bring a new collaborative project, as well as it will help at least in the field of radiation shielding to widen our expertise and hand in collaboration with the BRC and make these products more viable. So I thank you, sir, for bringing such eminent personalities. And also I would like to thank Dr. Manoj and his team for making a wonderful souvenir using radiation shielding materials. And then I would like to thank this our organizing committee, the coordinator, as well as all the members whoever has arranged this program very well, which was coordinated very well, and the programs were taken well on time. So also I would like to thank all the lab in charge. Wherever they have visited, they have accepted our invitation and they have made ready their lab properly, arranged the things and explained the things very clearly, and they have interacted with this guest also. So I would like to thank everyone for that also. So then I would like to thank this IT teams for providing the good support for making this program wonderful. And I would like to finally, I would like to thank all the other entire staffs of CSIR-AMPRI, including this administration, finance, and other technical staff, and also the photographer, whoever is involved and making this program very successful. So I would like to thank you one and all, and thank you very much.
Thank you so much. Thank you, Dr. Shabi. With this, ladies and gentlemen, we would like to end this program and wishes to see you soon. Thank you.